No, 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 no takers. Homework's going great.
So good.
No excuses, because the book is free. So, I ain't got the book. Yes, you do. You had the book before you even knew you had it. You had it. All right, so no excuses. All right, just to remind you guys, today we are going to go on a little field trip. I think we're going to get out a little early. I'm going to try to go about 11:45. We're going to take a little field trip. So we'll end up finishing up about noon, if that's okay. Is that all right? You guys are like, what the hell? Get my money's worth? All right. So if there's no questions from homework so far, let's see. Last time we left off with different levels of variables, I think, right? The different levels. Nominal, ordinal, interval, ratio. Yeah?
Move way over here so I'm not in their way.
Yeah, good.
In the corner.
Over there, sure. In the corner. So you're already there in case you do something wrong. All right. So that's basically the last thing I want to talk about. The section 1.4 is for you to read through. So you can do the homework, you can read through it, and you can ask me questions, right? There's a reason I'm here, and there's a reason you have a book. So I like to remind you guys of that fact every now and again by not talking about something. Do this real quick. That's going to come up eventually. So I just want to do a few quick little examples of the different levels of data. And while this thing is warming up, what about discrete, continuous? The differences between those. Can somebody give me an example of a discrete data, discrete variable?
Counted 50 tickets to a concert.
All right, I like it. So selling 50 tickets. So the number of tickets sold. So number of tickets sold. All right, it's really, really hard to sell 1.7825 tickets. Right? Plus, that would be horrible for you. Just over one ticket sold. Yeah. Sorry, I stole a few chairs, but not enough, I don't think. I could only steal so many. There you go, look at that. Chivalry is not dead. I like that. Cool. Something else? Another discrete?
How many people are in this room?
Good. How many people are in this room? You're a person. You can't say there's 57.6 people in this room. It's like, holy crap. That's freaky. All right, so number of people. Normally, not always, but you got to be a little careful. Very, very, very often, if you see the phrase number of blank, that's discrete. I mean, that means you can count it, which is part of the fundamental idea of discrete, that it's countable. I cannot count all the possible values for the weight of your book bag, for example, right? So weight of blank, right? Any true measurements normally will be continuous. What's another type of continuous data?
Gas prices?
We talked about gas prices, didn't we?
No.
We didn't? I thought for sure we did. So a normal gas price right now, what is it, like $2.89, and then they go out to the 9, like that?
Oh, yeah.
It doesn't go further than that, does it? So remember, continuous doesn't mean decimal data. Continuous means it doesn't skip any possible values. If it goes up a cent, it'll now be this, won't it? So didn't it skip? It skipped how many numbers did it skip? An infinite number of numbers it skipped. You guys cool with that concept? How many numbers are between 0.1 and 0.2? An infinite number of numbers are between them, right? All right. Hopefully you're cool with that idea. It's a little freaky when you first hear it, but you should have heard that before. So continuous does not skip anything. The fact that our scales even a digital scale only goes so far, is because we have to round somewhere. So I can make my measurements more and more and more precise. But you can't measure the number of people more and more and more precisely, can you? There's 57.00. No, there's 57 people. You can't make it more. Can you be more specific? No. You guys understand? Okay, good. I like it. So now that this thing woke up, I want to look at one little section that's actually assigned. It's number 39. I like it. I like it a lot. Freeze. Okay. So this is the other thing. That's discrete and continuous. Then you have the next kind of way to break things up: nominal, ordinal, interval, ratio. So just to pick a couple of them, and no, we're not going to do all these because this is homework. But like, for example, the colors of crayons in a 24 crayon box. What level would that be? We're not talking about discrete continuous anymore. That wouldn't make any sense. Is it nominal, ordinal, interval, or ratio? The colors of crayons in a 24 crayon box. Yeah, it's definitely not going to be interval or ratio, because those have to be what kind of things? Because interval involves doing what operation? Subtraction. Interval subtraction has to work. Ratio, division has not only just work, but it has to make sense. You kind of with me? So if I said, what is midnight blue minus forest green? What? Right? You can't subtract them. Is there a specific order to them? Not really. I mean, somebody could argue Roy G. Biv or whatever, but it didn't have to be in that order. If you open up, well, sort of, you could actually argue that a little bit. If you open up a brand new box of crayons, and it's not like sort of going from shades of whatever to shades of whatever, it's a little bit off-putting. And this is why, on a quiz, I'm going to ask you, what is it and why? Because very often in your explanation, I can see you understand the word means. And some things like that, I think, is actually on the border. I think they mean that one to be nominal, but you can actually argue for ordinal. And to me, what's more important is you understand what it takes to be that. Not, are you exactly correct on this problem? Because some of them are a little bit in between. How are we doing so far? Okay, good. Social Security numbers? We talked about those, I think. Nominal. They're just another name for you, right? Jersey numbers the same way. I could say, look at Frank running down the sideline, but normally what they say is, look at number 28 running down the sideline, right? All right, so there's another way to reference you. It's another name for you, is your jersey number maybe. What about this, the dates? 1066 is always referenced. What was that, the Battle of, I've even forgotten now. Oh well, it's not history class, I don't feel too. Historians are going to look at me like, come on, 1492, we all know that one, right? Hopefully. 1644, 1947, and 1944. What kind of data is that? All right, so now what's interesting is this. I haven't made this point yet, but everything that's ratio is also all of the other three. So the year you were born could be your name. I could reference you, oh yeah, that's that 1980 girl, right? Or that's that 1978 boy, or whatever. That could be your name. Are you with me? But it's more than that. It's not just nominal. Definitely there's an order to years, right? If I said 1972, 1987, 1974, no, there's a freaking order to those, Jeff, right? So, but it's more than ordinal, isn't it? What is it? Interval, because the difference between two, it makes sense. Right? I can tell how long a war lasted by saying the year that it started and the year that it ended. There you go. I can take the difference and tell you how long. Now, does division make sense? No, you'll get a number, but it won't mean a damn thing. Right? Because what's year zero? Is that the absence of time past? Year zero? Is that the absence of time past? Has the Earth been around for 2016 years? Has the universe been around? No, it goes back beyond zero, doesn't it? Are you? You guys all right? All right. Sorry. The heights of 21, 65-year-old women. What kind of data would that be? So the way you look at a problem when I ask you what level, you can immediately say, okay, is that really numbers? Is it really numerical? So that you know it's got to be interval or ratio, or is it not? So you know it's got to be nominal or ordinal. So off the bat, you know these are real numbers. The heights are numbers. So it's got to be interval or ratio. So why do you think it's ratio? I'm not saying you're wrong.
Because you can find an average.
So you got to be careful about that. When it says division makes sense, you take two data points and you divide them. Does the answer tell you something that makes sense? That's what it means. Not, can you find an average? Right? Yeah.
I guess because you won't find nobody that's zero height. So
But what would it mean? Like if I went fishing and they were like this one, and I went fishing with all these people, and this has happened actually. And he said, I caught a 10-inch fish, and this guy's like, I caught a 18-inch fish, and I'm like, I caught 0-inch fish. What did I really just say? I just said, I think I really have fish. So isn't 0 inches the absence of height? So don't say to yourself there can't be something like if I said weights of a chair. Is it possible for there to be a chair with 0 weight? But that doesn't mean it's not ratio, right? If that chair weighed 4 pounds and that chair weighs 8 pounds, isn't that chair twice 8 divided by 4 twice as heavy? 0 does mean the absence of chair mass, right? So 0, where are we at? Heights of it. So a 0-inch tall woman means there ain't no woman there. It's the absence of woman, right? Do you guys understand? So you got to be a little careful. So if one woman was, this is stretching a little bit, just to make nice numbers. Well, let's just do this. If one woman was 4 foot tall, another woman was 6 foot tall, what's 6 divided by 4? You can do it. 6 over 4 is? Yeah, 1.5. So isn't the 6 foot tall woman 1.5 times as tall as the 4 foot tall woman? So doesn't the number 1.5 tell you something that makes sense? So therefore it is ratio. Yes. So heights are a true measurement. It's ratio data. I like it. Cool. Yes, sir.
Why can't you do that with ages? Because you could say something.
Of course, I never said ages weren't ratio. Ages are ratio. Years are not ratio. Years you were born, years different people were born, they're not ratio, but ages totally. If you're 20 and I'm 40, then I'm twice as old as you. Right? Cool. All right. Sweet. Okay. All right, so I'm going to let you try the rest of those. Let's see. Blah, 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 blah. That was it. And the only other thing with definitions, this section here, oops, unfreeze. This section here, I think I assigned a couple of these. That's interesting. Notice that they're asking you many, many, many things, right? The variable and the data. Who remembers the difference? If you remember the story about, we wanted to say something about gross month students, the percentage that had a 4.0, right? The variable was something, and the data was associated with that somehow.
Variable is what you're looking for, and the data is the actual measurement of that.
I like it. So a slightly different way is the variable is the question you ask. So any situation they give you, you say, what would I ask people to do this? So like insurance companies are interested in the mean health costs each year of their clients. What would you ask somebody? Excuse me, sir. What would you?
Cost of your health care.
What you would just say, what's the cost of your health care? Now, they're interested in the mean health costs, so that after they collect all the data, that's the analysis they're going to do, right? But what's the variable would be the mean health, the health cost of each client in the sample. And the data would be the answers they give. Does that make sense? So always the variable is the question you would ask. Because why we call it a variable? Because it has a lot of possible answers. And the data are those answers. All right, I like it. I like it. Bless you, bless you. Okay. So that's why they say give examples where appropriate. So for the data on this one, you could say $2,000, $8,000, $100. Those are examples of the possible data points. All right, I like it. Cool. Okay. And then, of course, there was the sampling methods, cluster, stratified, convenience, those kind of things, right? So, for example, A teacher wants to know if her students are doing homework, so she randomly selects rows 2 and 5, and then asks all students in row 2 and all students in row 5, blah, blah, blah. Who remembers? Yeah, why is it cluster, not stratified? She took everybody from some. Stratified would be some from each, right? You guys, and what's really cool is stratified is some from each. SS, right? So cluster must be the other one. All from some. I like it. Okay, maybe. Good. Okay. So we're going to get into chapter 2 now. Oh, let me not make you guys sick here. Don't watch that. So, the very first part of chapter 2, and then next week we're going to get into using the graphing calculator. I forgot. I'll email out if I don't think I did. They have some workshops for statistics specifically for using graphing calculator, but they don't have them until week 3. I don't know why. But they do. They have them. But I'm going to assume that there are people in here that have never used the TI before, probably because there are, right? So every time we hit something that you're going to need the calculator for, we're going to go over it. I've got a calculator on the computer I can just splash up here, and we'll go over all the steps. And you've got that graphing calculator Bible on my website. It's up to you to go print it out if you want to, right? Cool. I like it. Maybe. Today we're going to do some stuff by hand. Next time we're going to start to see what the hell this expensive freaking little thing can do. We better be able to do a lot, right? Okay. So, chapter 2 is all about presenting data. Chapter 1 was about terminology and then sort of how to accumulate data. Chapter 2 is going to be, okay, once you've got the data, how do you show people what the hell you got? So there are a lot of bad ways to show data. Does anybody go on the website Reddit? Anybody Reddit? There's a subreddit called Data is Beautiful. You know, only stats professor would know that. But it's kind of nifty because they show a lot of cool shit, but they have all these different ways to show data. And you could have the same data and show it one way versus show it another way. And this way has a bigger impact and people can understand this way better. You kind of with me? So the way you present data is very important, right? And of course, with statistics, the big thing with stats is you can lie. You could purposefully show it and make it misrepresent what's happening. And the easiest way to do that is just mess with your scale. If you want to say, look at the big difference here, you don't start at 0, you start at like 5,000, and it looks like the difference is huge. When really, if you start at 0, it's like, oop, no, there's not that big of a difference. So it's a little evil when you see graphs in articles or something. You have to be careful about how they put them together. All right. So the first little thing here, the first couple things are going to be almost too easy to believe. You know, so don't get too complacent. Just appreciate that it's easy at the moment. So the first little dude, believe it or not, is called a stem and leaf plot. I think they call it stem and leaf graph. I like it. Stem plot. Kick ass. That sounds weird. Of course, there's also something we're going to learn later called a box and whisker plot. So the names get a little bit out there, but what the hell? So what the hell is a stem and leaf plot? So let me give you guys some data. Actually, let's do this. Anybody here not comfortable telling me your age? Good. I'm gonna do a stratified sample. So if I point to you, tell me your age.
23.
23.
18.
18.
20.
20. 18. 20.
49.
49. Sweet. I'll put myself in there. Yep, you.
16.
16. Sweet. All over the place. I love it.
I don't look at
Look at everybody's like, hell? You're kidding?
I got facial hair, okay?
Sorry.
20.
20. So far, not too surprising, right? 22? I like the way you sound like you asked me. I don't know.
29.
29. Let's see, way in the back, right there.
22.
22, and then right in front of you. Right there. You in the back, sitting down. Yes. 21. So 22, 21, and then you.
22.
22. And just so the last row doesn't feel too left out, way in the back. 23. All right. So we're going to do a couple things with this data. So obviously that is not in order, which is one reason why I liked doing that. I don't like making data up out of nowhere because then it doesn't mean a damn thing. But at least now you're like, okay, this is data that represents a sample of the population of our class. If this class is a population, this is a sample. And it was stratified because it took a few people from every row, right? Is that cool? I like it. Look at that. Stats happening. Right? So the stem and leaf plot is a semi-quick way to organize your data. The reason it's called stem and leaf, let me see. Well, no, this is fine. This will work fine. The stem is the first digit, possibly, or it could be more than that. We'll see the flexibility here. For this data, it's nice. There's no decimals. There's only 2 digits, right? Nobody in here was 100 something. That'd be neat. I want that day to happen. The oldest student I ever taught was 87. He was a cool dude. Anyway. So here's in this case, the stems would be 1, 2. Now, are there any 30-year-olds? Anybody? No, I'm sorry. Anybody in my sample that's 30? Sorry. Nobody in my sample is in their 30s, right? But you still put 3 down, and you'll see why here in a minute. I mean, you just put all the numbers down, the first digits that capture all your data. So nobody was 50-something, right? In my sample. Don't worry if you're 50. Didn't exclude you on purpose. I have no idea how old you are. And the leaves would be the second digits off of that first digit. So it's just a quick way to summarize your data, and it sort of puts it in order at the same time. So for the ones, let's go ahead and put them order as we write them down. Where are my ones? I got a 16, right? And a couple 18s. That's it, right? So I got a 16 and a couple 18s. So right now we'll go ahead. I want to write. You always have to write this down. This is a key, so people understand what that means. Because it could mean 1.6. So there's a lot of flexibility to what the stem and leaf refers to. So if my data was 2.3, 1.8, 2.0, this would look exactly the same. It's just that my key would look different. It would say 1.6 equals 1.6. How are we doing so far? Could you guys close those doors for me? Thank you. It's Tim Cliff. He's loud wherever the hell he goes. So how about my 20s? I got a couple of 20s, right? So 0, 0, and 3 20s. There you go. Is that all the 20s? 0, 0, 0. Let's see, who else we got? 20. How many 21s? 121. Congratulations. Go have a beer. 20. Legally this time. Sorry. 22s. 3 22s. Thank you. 23. A couple 23s, right? And then 29, is that it? Yeah, it's all my 20s, right? 29. All right. Okay, good. 23 was the age when I forgot how old I was. Because 21, you definitely know how old you are. 22, you're 1 year old in that. 25, you know how old you are. And what happens at 25? Your insurance goes down. All of a sudden you wake up, you know how to drive. So they make your insurance go down. 23 actually was like, how old am I? Yeah, that's right. 30 is nobody in the 30s. That's blank. And then 40s, there's me. And the dude right there. What's your name?
Dean.
Dean. All right. At least that I got in my sample. There might be more of us out there, but okay. So, 2 things about this. One is now my data is in numerical order, which could be important, especially if I wanted to find like the middle of the data. It's a little bit easier. So we're going to talk about all the different ways to measure the center of the data. But there's a lot of reasons why I want to put it in order. The calculator will do this for us, thank God. If I have a big old list, just got to plug them all in and it'll order it for us. Visually, I can kind of tell, you guys have seen bar graphs before, right? stuff like that. So if you tilt your head, it looks like a bar graph in a way, right? So it kind of shows you how distributed it is or not. Would you say that this data is really spread out? No, most of the data is concentrated here, right? So another thing we're going to talk about would be, variability in data. All right, I don't know if you guys know the word for it, standard deviation of the data. So we'll talk about that eventually. So I would say this data, even though there's a few outliers up here, right? Outliers. But most of the data is right there, right? So I wouldn't say this data varies much. You guys with me? All right, so far so good. So that was really simple, and from that simple thing I just did, a ton of stuff can be done and looked at now. Very, very nice, quick visual. All right, I like it. That's the stem and leaf plot. Let's do one more example with some made-up data that looks a little bit more disgusting, so you can see the flexibility you have, right? So everybody got what they want from this here. More than you ever want. Okay. So what if my data looked like this instead? 1.62, 1.67, 1.81, 1.74, 1.72, 1.80, 1.7, got it. 3, 1.75, 1.77, 1.81, 1.90. What if that was my data? Obviously, I don't want my stem to be 1. That wouldn't make any damn sense, right? Because then you just have one big, and it's like, tilt your head, oh, that's a good distribution. Does that make sense? What are my stems going to be? And every time I say that, I think eventually, my stems. 1.6?
1.7,
I like it. So there's a lot of flexibility built into stem and leaf plots. It's even more than this. Maybe I'll do one quick more example after this. And then after the 1.6, I think now we're all cool with this, right? I think I almost put this in order already. 2.7, right? 1.7, 2, 3. Are you guys cool? I don't have to do our set. You do the same thing we just did. What would the key look like? For example, it doesn't matter which one you pick, but means 1.62. I like it. Because it could mean 1.602, for example, depending on what your data looks like. Right? So the same chart could represent a lot of different possible data points. It just depends on your key as to how to read it. Please, dear God, you don't have to tell me 1.62 is 1.6-7 is 1. Don't do everybody. Somebody did that once. You just need one, right? That's the idea of it, just to give me the idea. Okay, good. All right. Otherwise, it defeats the purpose. Okay. All right, so let that be easy. Let the stem and leaf graph be easy. Okay. I should have kept that age data up there. Oh, well, too bad for you, Jeff. I don't do too much with line graphs. I don't think I assign too much line graph stuff. But those are just plotting points. So for example, for a line graph, it's exactly what it sounds like. We've already seen examples of line graphs, but if I said, what do I want to say here? Number of TVs and the frequency. So this is if I go talk to some people. And actually this is nice because it's getting into the next topic we're going to talk about. If I went around to people and asked, how many TVs do you have? Right? How many TVs do you have in your house, in your apartment, wherever you live? 3. All right. And then I walk around, how many TVs do you have? 7. All right. How many TVs do you have? 0. Okay, that's cool. You with me? So maybe I got, if people answered 0 through 4, let's say. All right. I was thinking about the commercial where the guy opened his drawer and there was a TV there because he had the soccer game going. He was a TV in the bathroom and there's a TV in the ceiling. So he didn't miss his second. So 0 through 4. And this would just be the number of people that said they have that. So let's say 3 people said they have 0 TVs. 7 had 1. 5 had 2, 4 had 3, and 2 had 4, let's say, for example. So then, how do you think you would represent that using a graph? What do these kind of become? X and Y points. In a way. So this would be, what would go here, do you think? No? Number of TVs. So it is exactly like, and you want the frequency to be this, because then the height of it would represent that's more or there. So you want it to be nice and meaty. So stem and leaf sort of takes that idea and turns it like this, because it's not its primary job, but it is kind of like a fringe benefit. If you turn your head like that, it does have that happen. Here I just want the height to immediately mean that's where most, if it's really tall, that's where a lot of stuff is, right? I want that to be the immediate thing I can get. So it would just be 0 would go to 3, 1 would go to 7, 2 would go to 5, so forth. And the difference here is you don't just put the dots, you actually do connect them. And the lines themselves don't mean anything, because I can't have somebody tell me that they had half a TV. I don't care how crappy you think it is. Either it's a TV or it ain't, right? So the lines don't mean what they mean in algebra. It's just to kind of contribute to the visual, right? Let's do a couple more. 3, where am I at? 2 was 5, 3 is 4, and then 4 was 2. Boop. All right. So it's a nice quick visual of the distribution of the number of TVs people had. Is that cool? All right, good. So far, so good. I like it. So that's not that evil either. That's like somebody said, it's just X, Y points. Would you ever want to sort these individually? Would you want to sort these? Do you see what I'm saying? Would you sort these so that you have 2, 3, 4, 5, 7? No. Why? Of course not. Why not? Because then you'd be lying. 7 people didn't say they had 4 TVs, right? So be careful about what you want to sort and what you don't want to sort. These have to go together. These have to go together because they're a point, X, Y. You would never sort one independently of the other one, or else everything in the universe would be a straight line. Like that. What the hell? All right, I like it. Maybe. Okay. And so we finally get to, I don't like some of the, well, again, I'm not going to agree with this book 100% all the time. And I don't like some of the examples they give. But bar graphs are normally for non-numerical data. All right, so let's get that straight. So bar graphs, I'm not saying they have to only be used, normally for non-numeric data. What I use for numerical data is called histograms. So a histogram, that's for numerical data. So a histogram would never have built-in gaps, because then it would look like I skipped somebody. A bar graph is no problem. So a bar graph, if I have a bar graph that looks like this, Democrats, Republicans, Independent, whatever, and then I say, okay, 10%, 20%, 30%, whatever. And I got crown, whatever the hell the issue is, right? You can all make up your own issue. We can read this pretty quickly, right? We understand what this means. We're not confused about the gaps either, because this is just the Democrat bar, right? There's no scale here. Did I put this out of order? Is this out of order? No, it doesn't matter what order I put them in, right? You guys with me? All right. So that's a bar graph. That's the same kind of graph we're used to, right? So you're going to have to make some of the bar graphs. And again, normally it's non-numerical data, so there's no real scale to it. A histogram, if I made a chart that looked like this, gather, and I had gaps, it would look like I skipped people. It would look like I skipped the people that were 15 years old or something, whatever those numbers mean. You guys understand what I'm saying? So the scale is continuous. Therefore, you don't want to have gaps unless you actually mean there was nobody there. You see the difference? So the gaps here are kind of built in. Of course there's gaps. This is a different category than this. This is a categorical data. Here, there's a scale. It's continuous. If there's a gap, you better mean that there was nobody there. I like it. All right, maybe. Maybe. Yes, ma'am.
So you're saying you want the graph, those to be touching?
Yeah, for a histogram. So let me give you this. Let me show you this. Even before I tell you any more than that, I'm going to see if you can answer these questions. This is actually a problem I gave on my first test for the last few years, and I'm like, I probably should make a new problem. So I'm just going to show you this one, and you get a different problem. Chalkboard. I miss chalkboards. Oh no, these you can't. You know, these are. See, there's a low odor. You can't even get high for these things. That used to be the fringe benefit of whiteboards. All right. Sorry. So someday this will turn on. We're going to learn how to create histograms. So I'm going to show you a created histogram and ask you some questions. And that might help us when we go to create it, we know what we want it to look like. So it's possible we've seen something like that in the past. Can somebody maybe shut off just experiment, turn one of them off. So turn that one back on and turn the other one off. Let's see what happens. Oh, that was not much. Holy crap. Can you guys see that?
Yeah.
Everybody? Okay, all right, that's fine. Thanks, man. So Johnson & Johnson sampled several male and female consumers, asked how many weeks a bottle of shampoo typically lasts them, right? The histogram below displays the responses. So let me see if you guys are with me here. So this axis represents what? Number of weeks. So some people had it lasting 120 weeks. All right, holy crap. How long, how many weeks in a year? 52. So even I'm not that bad. I mean, that's like maybe they have 3 tufts of hair or something. You know, like, okay. And then this, so for example, from 40 to 60 weeks, what does this height represent? 2 people said that. Okay, so my first question is, how many consumers did they actually talk to? Total.
20.
So how tall is that first bar? It's a little tiny bit evil, but is it this long up there? How tall is that first bar? 11. I like it. It's not 12. It's not that big, right? So in this first bar there are 11 people, and then there are 6, 2, so it's the 11, 17, 19, 20. So 20 total. Good, I like it. 20 total people were surveyed. I like it. Let's see where. What do you think this means, class width? What's a class mean first? Let's see if you guys, what do you think class means in terms of this picture? Well, okay, I got you. So that's the answer to what is the class width. It kind of makes sense. It's the width. But if you see that the width is 20, then you know what a class is. How many classes are up there? Yeah, 1, 2, 3, 4, 5, 6. There were 2 classes that had nobody in them. So this is what I meant. You better not have gaps everywhere, because the gaps mean nobody was there. That's important. So we'll see what that means when we try to create one of these ourselves. Depending on the way you do it, you got to be careful about not letting there be any gaps, because then you're telling people there was nobody there, right? All right, maybe you guys understand. Maybe. Okay, so a class is just how you decided to break up all the data. So it was from 0 to 120. What's 120? That's the distance I had to go, right? 120 was the largest possible thing somebody could have told me. What's the 120 divided by 6? 120 divided by 6? 120 divided by 6? 20. There we go. I don't know why people told me 6. So see, that's the width. So if I know how far I've got to go, and I pick the number of, so what I usually say is if I wanted to, for some reason, put wood paneling on this wall, right? Say I just want to, right? I thankfully I don't. And I know this is, 30 foot long or something, right? And I want to use, I don't know. Well, if I want to use 10 panels and it's 30 foot long, how big does each panel have to be? 3 feet. I mean, you see, that's the physical reality behind creating this. So that I had to go from 0 to 120, and I want to use 6 rectangles. How wide does each rectangle have to be? The range of the data divided by the number of rectangles I want to use. Maybe we should write that down. So the class width, let me make this a little more formalized. The class width, I need to hire a camera person. All right. Class width equals something called the range. Does that word make sense? The range of the data? Well, how far does the data range? From 0 to 120. So the range is 120. Divided by the number of classes. That's the class width. That's how wide each class is going to be. That would tell you how to make your scale. How are we doing so far? Decent? This is a little bit freaky until we actually get our teeth sunk into an actual problem and we have to do it. I'm just trying to prep us for it. All right? Let's see, what do we have left? For what percentage of the sample does a bottle of shampoo last longer than 40 weeks? 50?
15.
15. So how'd you get that?
Because there's 3 people.
3 people.
20 overall.
Beautiful. So 3 divided by 20, or just 3 out of 20 is the same as 15 out of 100, so 15%. Is that cool? 3 people out of part A, 20 total, and that's how you get the percentage. I'm glad that people seem to understand percentages a little more. For a while, I think what they were teaching in high school, for some reason, people had less and less understanding of percentages. I think it's coming back now. I don't know if that's the Common Core, whatever the hell. I don't know. Right? But people just didn't understand percentages. But it's a part divided by the whole. That's the basic idea of a percentage, right? So 3 people out of 20, that's 15%. Cool. How are we doing so far? Oh, some of you guys look like you want to hurt me. You got to speak up. You got to let me know what part of it's troubling you. Or hold your peace for a while. All right. Oh, shoot. I think that was it for that, right? Yeah. Okay. Got to keep an eye on the time, too. Where's the clock in this place? Is there a clock in this room?
I don't think so.
It's 11:60.
There's no clock in this room. Yeah, okay. And you guys don't even know what to look at. Because normally at some point, close to, or sometimes at the beginning, everybody's head's kind of like looking at the clock. And I'm sure you guys had this moment where you're like,
That was like me the other day. I was like,
really?
Oh,
Because I like it when the clocks appear, because then I at least feel like people are looking at me. But there's no clock, so too bad for you. All right, too bad for me too. So if somebody's got the time, just make sure when we're getting closer to quarter till, let me know, because that's when we've got to wrap it up. Okay, so what we're going to do, I think what we're going to do, I thought I was going to have questions and stuff. We could do a little bit more than I thought. We're going to try to do a simple problem. I'm going to give us data that's already in order. So, because tomorrow, I mean, relative to the class tomorrow, so like next Tuesday, we're going to have a problem where we have to use the calculator to help us sort stuff and do things like that. So today I just want to focus on by hand stuff. So let me show you how to create the histogram. Now that we know what the goal is, I want it to look like this. Yeah, we even know some math that I got to use. The class width calculation. Oh, let me turn that off. Can you crank the light back up back there? Okay. All right. So, let's get some simple data up here. Let's see. So I'm just going to make up some data. I'm going to put it in order as I make it up here. Oh, sorry. I don't want to do that weirdness. Not make it too weird yet, Jeff. All right, that's fine. Let me go on. 1, 2, 3. Good, that's good. I like it. So copy that down if you want to play along. Or don't, just play along. It's on the video. If I'm facing the right way. All right, so that's in order already. If it wasn't in order, we would have to take a minute and put it in order to help us out. So help me out. First off, let's do this. Let's see if you guys understand really what that meant. What's the range of this data? Yeah, so I got to be careful. I need to be a little specific. That's how far the data goes. The range is the actual length. So how long is that? 40. So the range in general is high minus low. Cool. That's how far it ranges. So it goes from 47 down to 7. So the range is 40. I like it. In order for our picture to make sense, obviously I don't want to use 2 classes. Would it make any sense to have these 2 ginormous rectangles? There's the distribution. 1 would be stupid. So normally we use somewhere between 5 and 10. Because how do I figure out the width? I take the range divided by the number of classes I want to use from 5 to 10. When do you think I use 5 versus when do you think I get closer to 10? When do you think I use 5? And how many should I use here, do you think? Should I use 10 classes? Probably 5. Why?
It's more accurate. You're showing, the graph.
What about this sample tells me I should use 5? What kind of sample could I use 10 for? This sample, is it very big? No, it's only 15. So the larger the sample is, the more classes I can use. Does that make sense? Because think about it. If there were very few data points, my histogram might end up looking like, this. It doesn't really tell me much. There's 1 data point in each. What the hell? So the more data points I have, the more classes I can use, because the more data there is to populate each class, the more sense it would make. I don't know if you guys can understand. Okay, maybe. So anywhere from 5 to 10, there is a formula for it using logarithms, but who cares? Basically, if it's a small set of data, 5 or 6. If it's bigger, 7 or 8, we're almost never going to need 9 or 10. I'm not going to give you a stupid big, just keep you busy problem. I'm not going to do that because I don't like them either. All right, how are we doing so far? So how many classes should I use here? 5. Okay, I like that. And I kind of like the fact I didn't do this on purpose, but 5 goes into 40 exactly, doesn't it? Which is actually a sort of a problem, but we'll see what happens. We'll show you. I'll show you. There's only one of me up here. Sorry. So if we use my friend Harvey, he's a co-teacher, 6 foot tall, right? If we use 5 classes, what will the width be?
8.
Yeah, so 40 divided by 5. If it did not go in evenly, so go back to the example of paneling that wall. If it was 30 feet and I wanted to use 7 panels, 30 divided by 7 doesn't go in evenly. So if I rounded that down, go with me. If 30 divided by 7 is 4 point something. So if I rounded it down to 4 and I use 7 panels, 4 feet each, would it cover the whole wall? So you never round down. You always round up. Because it's better to overcover your data. All the data points have to have somewhere to go. If you round down, now these bigger data points have nowhere to go. Aww. Right. So Sarah McLachlan will sing for their commercial. All the data. Sorry. All right. So now I know my width. I know my range. How do I set up? Remember on this, it was 0 to 20 and then 20 to 40. So there's two numbers that are important. It's how wide each of the class is and where do I start. Once I know those two things, bam, 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 everything sets up beautifully. So where should I start? What should be my first data point? What should be you don't have to start at 7, but normally you should, right? You could start at 5, especially if your width was 5. That would make sense, 5, 10, 15, 20. You guys understand what I'm saying here? So there's a lot of variables involved. That's why one person's histogram could look very different from another's. If you use 6 classes and not 5, your histogram is going to end up looking a little different, isn't it? All right, I like it. Maybe. Okay. So let's say I start at 7. I'm going to show you, I forget the way the book does it now, this book. There's always 2 ways that I show people how to do this. Oh, how do you do it, book? Barf. All right. I'm going to show you the best way to do it. I figured that might be a good way to do it. All right, here we go. You ready? So for example, on that, I should have left it up there, but it went from 0 to 20. So how would you define the data points that would go into this class? They're anywhere from 0 to 20 weeks. So mathematically, I would say something like this, in between 0 and 20. But notice, you'll see why I do this here in a minute. Just go with me for a second. You got to see this, and then you'll get used to what the hell's happening. So I want to go from 7. Now let me leave that blank for a second. What would the next one start at if I know my width? Where should the next class start? Considering what my width is, how wide it is. It's 8 wide. So if that starts at 7, the next one should start at 15. All right, how are we doing so far? Should definitely start at 15. If the class width is 8, that one starts at 7, the next one must start at 15. Then I can see the 8, can't I? Is that cool? I like it. Some of you guys might have been concerned about this then. Well, I can make this 15 as long as I say this. If I say this, what's wrong with that? Where would 15 go? Either one. And that's no good. If I put them in both, I'm over-counting, right? So you want to make it very specific. And some of you guys are like, inequalities? Why? But come on, not a big deal here. All this means is the data points that are between 7 to really 14 here, right, will fall in that first class. And the reason I like this, there's another method that works well with whole numbers, but that's all it works well with. The minute it's decimals, it goes to shit. This, I don't care how big my decimals get, there's no question. So if my data had 14.987, where would it go? First one, no question, right? All right. So that's why I like doing it this way, because no matter what your data looks like, this process will work. There's another way to do it that the old book that I used to use used, and oh my God, it gets so freaking confusing. This is the way that I was taught. Right. Which doesn't mean it's the best way. It's just there. It's just the way. So now what's beautiful is what's going to go here, of course.